Alrighty, hello, welcome. How's it going? Today I'm going to look at instanced rendering. So so the game engine sort of exists on a spectrum. On the one case, we could have super dynamic draw calls, even going so far as to generate shader code on the fly in runtime. That's a bit much. But on the other hand, we have sort of extremely rigid, everything set up like a lane, and everything's set up ahead of time. We understand what the convention is, we set things up and we draw them. And I tend to actually gravitate more towards that rigid way of working because we get a lot of performance benefits. So if you were to look at a standard game, you'll find that yes, we could be drawing each object individually, or we could set things up ahead of time as much as possible and really reduce the number of draw calls. That does not, for something like Metal, where the draws, like all the operations are recorded in a rendering coder and then that's sent over to the graphics card, it doesn't affect the GPU time as much, but it does affect the CPU time because those operations still need to be recorded, if that makes sense. Anyway, so the basic idea is, declare as much data as possible up front and then reduce the number of function calls. So here is what I've got currently. Now, in previous videos, see I've got that vertex buffer up there. In previous videos, I went through the exercise of loading in a bunch of individual models and sticking them together in something called a vertex menagerie. Basically, it's a really big model, which actually has subcomponents, which are each of the individual models. And then also, right down the bottom, you see the material layers. We've gone through that as well. So you load in the materials. Each one of them is an individual layer in this set. Okay, but what I was doing is a single draw call where I would declare as the fragment shader bytes, I want to say, the material index, and I'm not going to do that anymore. So the big thing that I've got right there in the middle is the instance payloads. Now, when I say payload, I just mean a custom data structure, a custom chunk of data, which is used in rendering. So what do we need to know? We need to know the transformation, basically where we're drawing the thing, and we need to know which material it is, if that makes sense. But if we can record all of that into some sort of buffer and then upload that buffer and then run instanced rendering, then we've declared all that data up front. And we can do a lot in a small number of draw calls. I think I forgot to define instanced rendering. So if you're not familiar with what instanced rendering is, we could have a single draw call that says, hey, draw these vertices, and it does its thing. But then we could have an instance version of that call where we say, hey, draw these vertices and do it 1,000 times. Okay, well, if we do that, we'd better have 1,000, model matrices or something defined, sitting there in the buffer, ready to read from memory. But provided we have that, it should work just fine. Yeah, cool. So we have, instead of a whole bunch of draw calls, we just have one draw call for every type of mesh that we want to draw. And I won't be looking at this at the moment, but what you can do is you can even get the GPU to record draw calls. So you can even reduce things further. And now I've written here next topic, skeletal animation. It might be a little ambitious, but I think it's good to bear in mind because it uses a similar philosophy of recording a whole bunch of transforms up front and then working with that. Okay, but that's been enough of me rambling. Let's head over and have a look at the code. Okay, so here's the code. I'm not going to explicitly go through every single line because it's a lot of little bits of refactoring. But I'll try to give a brief overview. It's linked down below. You can have a look through, get comfortable with it. The basic idea is that, we can get rid of that, can't we? Okay, the basic idea is that we have these things, these entities, and this entity is just a basic thing that exists somewhere. You can get a model transform for it. And then in addition to that, we have objects which inherit from that. So we have like a billboard, which inherits from an entity. So we set it up with a position and everything. And the only thing that changes really is that every frame it updates its rotation. So it's always facing towards the camera or something. But that's not super important. I guess the really important thing to know is that we have this base class which has a function to get its representation, its model transform. There we go. Okay, so knowing that, previously I had a if I remember this correctly, because it has been a while since I did this refactor, but previously basically all of the objects which were renderable were published. But now, instead of that, I've got a dictionary where the keys are these integer codes, which are over here in definitions. If we go down here, I've defined these codes for each different type of object. Okay. And then corresponding to that, where are we? Corresponding to that is a list of entities. Okay, so think of it like all the game objects are bundled together into a single dictionary. Like, here are all the ground tiles, here are all the boxes, here are all the mice, and all of that. Okay. Now, in addition to that, I need to know the first instance and the instance counts. So for instance, let's say I want to draw all of the ground objects and then all of the mice. Well, those ground objects and mice are going to have all of their transform data written to the same buffer. When I draw the ground objects, I need to know, okay, we've got the instance variable, which will start at 0, and we're going to draw 7 instances. And then when I go to draw the mice, I need to know, okay, the first instance there is going to be 7, because we've cleared the first 7 ground tiles, for instance. For instance. Okay, so again, the key here will be the object type, and then the associated value will just be some sort of integer. Okay, so we have the constructor. Not too exciting, you can look through that in your own time. It's basically just looping through, making a whole bunch of objects. That's great. Now, the new one here is this capture renderables. And what that's going to do is it's going to record the appropriate first instances and instance counts. And yeah, it's also going to record the lists of objects. So this is for the most naive case where basically everything is changing every frame, because if we can at least cover the most naive case, that'll fix most things. All right, so to start with, we have the cubes. So we say, all right now we haven't seen any cubes yet. And we'll set the first instance to this variable, which starts at 0. We look through all of our cubes, we pop in the current cube that we're looking at, and then we add the number. Okay, we set the number of cubes as the number of instances that we want to draw of that thing, and then, increment the offset so that when we record the next one, it will start after all of the cubes. For instance, I know I'm digging a little bit into the weeds here, but that's the cubes, and all the other objects are more or less going to follow the same strategy. So just think of it as we're setting up these dictionaries of where is the first object in the set of things that we're drawing, and how many of those things are we drawing. The rest is just details. Now, I am big thank you to Copernicus in the Discord and to anyone else who had a look at my code, because I was having issues getting this stuff running, and they pointed out that I just need to be very careful about defining these things in the same order that the engine is expecting them, if that makes sense. Anyway, so I'm going to pop over to the renderer now. So the renderer will do its thing. Everything's pretty much the same until, let's go to the draw function. Okay, so I'm just looking through here. So we go to the draw function, and the first thing we do after making the render encoder is we draw all the lit objects. Now I think I've done this in the lit objects. So we go to draw all the lit objects. There we go, okay. And the first thing we do is we start setting up all of the uniforms. We bind in the resources that we're going to use. Remember, the idea is to get as much up front as possible, bind everything, and then just let it go. And it's this line here where we set the vertex buffer and we use this prepare scene. So if we go right up above, this prepare scene function will basically read off that dictionary of renderables, produce a buffer, and return it. So that's what it's basically reading all the instance data up front and sending it to the graphics card. Okay, so prepare scene. Now again, this is a little funky, so I'll try to give a brief overview. So first of all, I need to be very careful about the order in which I read off these objects. I need to read them off in the same order that they were popped in over here, and also the same order that the engine is going to be drawing them, just to be completely safe. But anyway, so we have this payloads, which is a list of instance payloads. If we go to definitions, here we go. Instance payload is holding a model and basically the color and texture ID. Color in the case of a light, texture ID in the case of just a thing with a material. But again, just think of it as this is all the info that we need to draw any given object. Okay, so the goal is to populate a list of those. So we go through the objects and we loop through them and pop in, the model transform and some stuff, the color and all of that. Fine, all right. So then the next goal, after we've populated this list, is to write this list to a buffer. So if we pop right down the bottom here, we have this, we're making a buffer with these bytes, which have been copied, like we're copied over all of that instance data, all of that list. So that's fine. Return the buffer. Okay, great, awesome. Now, what's happening here, this is a little funky. This is a metal specific thing. So with buffers, if the size of the buffer exceeds 4 kilobytes, it needs to be page aligned. And I found this online. This is just a formula. This in hexadecimal is 4096, which corresponds to 4 kilobytes. So we're aligning it to a page size of that. To be completely honest, I don't quite understand the math which is going on here. I've looked it up, and explanations of it have been few and far between. I don't know, I might look it up in future. For now, I'm using it as a black box. So this is just aligning it to a page size of 4 kilobytes. It's just a thing we need to do, and then it works. So that's being done here with this POSIX mem align, and then mem copy. Okay, great. I have talked too much, in fact. So just think of it as we grab a list, we populate it with all the data we need to render, put that data, that list, into a buffer, send that buffer to the vertex shader so everything is declared up front. Then when we go to draw things, that's all debug hell that I was going through. Okay, when we go to draw things, great, we just do it per mesh type, and we just need to look into that dictionary to get the instance counts and the first instance, and we're just throwing it over at the GPU and we're saying, hey, do this thing 1,000 times or something. Okay, now, you know what? I should just briefly run this because I've talked too much. Okay, so, gonna run it, have a look at it. Ooh, build failed. I love this. I love it when it fails and it's not something I did, but some weird Xcode specific thing. I think if I just switch this Yeah, failed to register. Okay, if I just switch this to a 2 or something, it should work. I love Xcode. I love it. Okay, there we go. So we see the same thing that we were seeing before, but under the hood, this is more performant and it scales better because we're sort of doing less CPU work. Okay, so let's have a look at the shaders. Sort of hide that. Let's go to the shaders. Okay, great. It's maybe unlit shaders. It might be a little less dense. Okay, so here we've got our vertex shader. Now we've got these vertices, of course, and then we've got this instance payloads pointer. So that's the set of all the data, which is just sent through once. Okay, now all we need to do is we've got vertex ID, but then we've also got this instance ID. And that will be populated for us by the shader when that draw call comes in. So it might be, hey, you know, this is instance number 3, this is instance number 30 or something, and we use that to index into this. So just look at where we're using that. Yeah, right. So to get the model transform, for instance, we index into the set of all payloads, fetch out the model, and same thing down here with the color and material ID. Now, that material ID is a float, and that is being used down below in the fragment shader to get the appropriate, to get the appropriate layer from all the textures which were sent through. Anyway, look, I understand this session has been a little bit talking in circles because the fundamental concept is quite simple. It's just pre-record all of your model transforms and then read them off, and you can do less draw calls. That's it. Now, if we look through the other shader, we'll see that essentially it's the same. It's just that it was a bigger shader, so there's more stuff to read through, but it's the same thing. So right here we've got this pointer, and this is actually the same thing, the same resource for both shaders. Great. And then we've got the instance ID up here, and same thing. We use that to index in and get the appropriate model, and yeah. Oops, where are we? Model and material ID. We don't use the color. That's totally fine. Look, so I'll probably leave it there. Yeah. I hope you enjoyed this, and, you know, as always, have a great one, all the best, and I'll see you around. All right, bye.